In a class of 45 students, 28 offer chemistry, 25 offer biology. If each student offers at least one of the two subjects, calculate the probability that a student selected at random from the class offers chemistry only. Now, we can see a set question that has a relationship with probability. So, set and probability, they go side by side. Although you don't need to bother yourself whether you understand probability or not. Yet, I understand when you attempted your junior WAEC or your grade 9, your junior secondary, your junior high school, you were taught probability. But trust me, this probability is not a big one. So now let's connote our statement. Remember, it says U is 45. That's the total number of students. Chemistry, it's 28. Biology, it's 25. Chemistry intersection biology, if each student offer at least one subject. So we don't know that. Let's call that X. Now let's draw a Venn diagram to make it easier for us. So always learn to draw your Venn diagram. It's going to give you a descriptive measures of how to solve the question easily. Now remember, this is your X. Now this will be your chemistry and this will be your biology. So now chemistry is going to be will be 28 minus X to get only the people offering chemistry, while our biology is going to be 25 minus X. Now, I don't think there's anybody that does not offer, because the question says if each student offers at least one of the two subjects. So we don't have anybody not offering any of the two subjects. So now our U, remember our U is what? 45. So when we sum up everything in the elements, we're going to get our U. So this is going to be 28 minus X plus 25 minus X to give us our U, which is 45. So we are going to add 28 plus 25. So collecting our like terms, 28 plus 25 is going to give us 53. Now we have minus X plus X. That will give us 0 minus X is equal to 45. Now collecting our like terms, 53 minus 45 is equal to X. Therefore, our X is going to be 8 when you do that. Okay, so now we've been able to get the number of people who offer the two subjects, which is 8. Now the question says calculate the probability that a selected student at random from the class offers chemistry only. Okay, so let's get chemistry only. Now remember, our chemistry only is 28 minus X, which is going to be 28 minus 8, and that will give us 20. So now we know the number of students who offer chemistry only as 20. The probability of chemistry only, remember your probability, you do, it will be probability of chemistry all over probability of the total, which is U. So this is going to be 20 over 45. What can divide through here? I think 5 can divide. So we will get 5 into 20 will be 4, and 5 into 45, it's going to give us 9. So our final answer, it's 5 over 9. So the correct answer here, it's C. So we are going to mark our C. Okay, so that will take us to the next question, which says, given that U it's 1, 2, 3 up to 10, P is equal to X, where X is a prime, and Q it's Y, where Y is odd. Now, from this question, you can deduce that P and Q are subsets of U. Remember when we talked about subset, we said P and Q are the children's set, are the child set of the universal set U. So the question says find P complement intersection Q. Okay, so our U is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then our P is going to be all the prime numbers, so which are 2, 3, 5, and 7. Our Q are the odd numbers, which are 1, 3, 5, 7, and 9. Okay, so P complement, remember when we talked about P complement, we said P complements are those numbers not found in P but are found in U. Now, what numbers are not in P but are in U? 1 is not in P. Okay, 2 is there, so we will not use 2. 3 is in P, so we're not using 3. So 4 is the next number. We have 5, so we're not taking 5. So 6 comes next. we have 7, so we're not taking 7, so we have 8, 9, and 10. So P complement intersection Q, what are those things that are common to P complement? Those numbers that you can find in P complement and can also find it in Q. So 1 can be found in both. The next number we can both find is 9. Okay, so P complement intersection Q is 1, 9. So our correct answer here is going to be A. So I'll mark A as the correct answer. And that will take us to the next question. Okay, the next question says if X is equal to 0, 2, 4, and 6, Y is 1, 2, 3, 4, and Z is 1, 3. These are all subsets of U. Find X intersection Y prime union Z. Okay, so now our Y prime, remember, those things that are not, first of all, I think we need to list our universal sets. So let's list it. So U is, remember, it says 0 is less than or equal to X and is less than or equal to 6. So that is going to be 0, 1, 2, 3, 4, 5, and 6. Now be careful not to exclude 1 because it says it's using the sign less than or equal to, and also it's using the sign less than or equal to 6. So that is why 0 and 6 are inclusive. So our X is 0, 2, 4, and 6. Our Y is 1, 2, 3, and 4. And our Z is 1 and 3. Okay, so from here, we can get, so to perform X intersection Y complement intersection union Z, the first thing we need to do is let's get our Y complement. So our Y complement are those elements we will not see in Y but can be found in the universal set. So we have 0, so 1, 2, 3, 4 is out of it, and we have 5 and 6. Okay, so Y complement union Z. So remember our union, this is when you get union, you combine all the elements. So Y complement union Z is going to give us, so I think I'll take the numbers in ascending order. That will be 0 comes first. I think there is 1 in Z, 3 is next, we'll have 5 next, then we'll have 6. Okay, so then finally, to get our X intersection Y complement union Z, that means we are going to be comparing Y complement union Z with X, and we're going to find the numbers that are common. So in there we have 0, it's common, 1 is not common, 2 is not common, 3 is not common, and 0 it's common, 2 is not common, 1. I think the next number that is common it's 6. So that will be 6. So it's 0, 6. So this is our final answer, and we can see that option B is correct. Okay, so that will take us to the next question, which says